Alright, so this is for nomenclature of alkanes, and this video in particular talks about your straight chain alkanes. And so before we start really doing anything, we have to know the rules. So rule number one is you're basically going to just find the longest continuous chain that you can find. Right, so you're just going to count in either direction, and you're going to find the longest continuous chain. Now, rule number two, what you're going to do is you're going to find and identify any and all substituents, right? So it makes it easier if you just find them and go ahead and name them too. So you're going to find and name all substituents that are contained on the chain, right? This may also include functional groups. But for now, let's just refer to alkyl and halo substituents. Then the third rule is determining where to start numbering. And you're going to start numbering the chain at the point that will give basically all of the substituents the lowest overall number. So here we're concerned with getting the lowest number that we can. So sometimes these little guys are like a small little puzzle, right? But with a little practice, you begin to kind of get used to this a little bit more. Now, so again, we're finding the starting place that will give us all of the substituents in the lowest overall number that we have. Now, it turns out that this often isn't enough to help us with some of the ambiguity that might arise. So what we're going to have to do is we're going to have to kind of come over here and give us a little bit more of these sort of sub-rules, some rules to deal with more complex or complicated structures. And the first of the sub-rules is that if you have two or more chains that have the same length, so for instance, you find a way to number it and you go one direction and you get the same number as if you go in the opposite direction, you then need to figure out which one is your main chain. And here what you're going to do, you're going to choose the one that will give you the most substituents. So what that means is you may have to break up, say, a complex substituent and name along the line of the complex substituent so that you have more substituents there. Okay, so choose the one that has the most substituents. Now, the second part of the sub-rules also has rules within itself, just to make it a little more complicated for you. So if you find that the chain has, the two ends of the chain have substituents that are equidistant from each other, there are two things that you need to do. Right? There are two parts, and you need to follow the rules as far as you do the first one first and then go to the second one. Okay? So the first thing that you need to do, if the substituents are what we call equidistant from the end, right? In other words, they're the same number of carbons in from the end on either side. The first rule is look and see if there is a third substituent. If there is a third substituent, then what you're going to want to do is number closer to the end that will give that third substituent the lowest overall number. Right, so you want to number basically closer to that third substituent in that case. Right, now, if there is no third substituent, right, then what you're going to do is you're going to number closer to the group that would come first alphabetically. Right, so for instance, if you had an ethyl and a methyl, right, you would choose the group that is higher in the alphabet. So E would come first, so ethyl would be first. Now, it's important to note when I say this as well that remember that prefixes such as di, tri, tetra, and such do not count in the alphabetical process. So let's look at some examples. So here's our first example. We'll keep it simple, right? So we'll just say I'll put, say, maybe a methyl group here, and put another methyl group here, and let's just put another one there. And so now I have my compound, and I need to figure out where I'm going to start naming it from. I can start numbering from the right or the left, you see with the arrows, but if I start from the right, then that would give the first substituent the number 2, so I'm going to start there versus numbering the other direction. If I numbered in the other direction, that would give the first substituent the number 4. So now I've got everything there. I just need to figure out where everything is going to end up with. I have 7 carbons, so that's a heptane. So I'm going to just come over here and write heptane over there. So now I've got my parent chain all figured out. Now I just need to add in my substituents. So you can see I have 1, 2, and 3 substituents, and they're all methyl groups. So I need to first add the locator to tell people where these are on the chain. So I have one at carbon number 2, and I have one at carbon number 3, and one at carbon number 4. So this would be trimethyl. Now notice that I have all of my numbers separated by commas. So, and then my words are separated from numbers by a dash. So that's going to hold true. That's going to be sort of the standard rule that we're going to use for writing these things. So now if I want to put all of this together, I'm going to write 2, 3, 4 separated by commas, and then finally the dash between the word and the number, trimethyl heptane. And that is how you would name this guy. Let's look at another example. Let's make this one slightly more complex. And now we can see that we have our groups here. We have to start on the right again, just as we did in the one above, because the one on the right is closer. And notice that I have 2 ethyl groups on the end on the right, so it doesn't really matter which one I start with. I can start with either one. I'm going to always end up with the ethyl on carbon number 3. So we'll just start numbering here. 1, 2, 3, 4, 5, 6, 7, 8. So this would be my parent chain now, and it would be octane because I have 8 carbons. And I have these 2 ethyl groups that you can see that I was just circling, and finally this methyl group. So I need to come in and add these ethyl groups here. So they're on carbons 3 and 5. So I'm going to write 3, 5 dash diethyl. That's the one substituent group there. Now I have to take care of the methyl. We can see that the methyl is on carbon number 4. So now I just need to put all of this together. And you can see that I have 3, 5 dash diethyl. Now I need to put another dash because I'm adding another number. So 4 dash methyl, and then add in the parent chain, octane. And there you go. That's the name of this guy. Let's look at an example that is even further has some further complexity to it. So I'm just going to draw this here. Let's add an ethyl. Let's add this guy. This is an isopropyl group. Now, we need to find the longest chain. And so you can just count up from either side, as you can follow my cursor. And it's counting there. I'm going to count from all ends. I'm going to find the one that gives me the longest chain. All right, so you want to just kind of go through this routinely, and eventually you'll begin to where you pick it up. As you watch my cursor, you'll begin to kind of pick it up as you can, as you'll start to see it more off the bat. But sometimes, especially on an exam, it's probably better to just go ahead and trace the compound first. Now, notice that if I start from the right side, I have a substituent that's equal in the same number of carbons if I start from the left side. So now I have to use one of those sub-rules. And what I'm going to do is, it doesn't matter I don't have a third substituent. So I have to go by the alphabet here. And we're going to name this guy down here at the bottom as either isopropyl or 1-methyl-ethyl. Okay, so my longest chain is octane, so we'll start 1, 2, 3, 4, 5, 6, 7, and 8. And notice I started from the left. I started from the left because there is an ethyl group there. Ethyl comes before I for isopropyl, or it comes before M for methyl. So I have to start from the left. It is correct to use isopropyl if you wish, but I often recommend using just the standard nomenclature, which in this case for our group here, which is a complex substituent, I would recommend using basically the standard nomenclature, which if you look where the arrow is, that would be carbon number 1. So carbon number 1 is always the first one off of the chain, right? And then the next carbon would be carbon number 2. So that will give me an ethyl, or has the main chain there, but it has a methyl on the first carbon coming off of it. So what I'm going to do is I'm going to put 1-methyl, and then at the end add ethyl. Alright, so now we have all of our substituents named, and we just need to basically put it together. So I'm going to write 4-ethyl because that is our first one there, because E comes first. And now I have this complex substituent, right? So what I have to do is I have to figure out, okay, this is off of carbon number 5, right? So, but its first carbon is named separately, remember? So I have to put 5 dash, and then now I have to have parentheses. So now it becomes 1-methyl and then ethyl, and then octane. So remember that you have to tell where the complex substituent is, and that's where the 5 comes in. And then I have to break down the complex substituent, starting with the first carbon off of the chain. Right now, there is also this isopropyl group, so it would also be correct to name this as 4-ethyl, 5, isopropyl, and octane. So there you go, there's the name for this compound. That's a little bit more complex, and we had to use one of our sub-rules to figure this guy out. Let's look at another example here. And so I'm just going to draw in, let's have these 2 methyl groups on the end and the chloro group here. Again, we have it's easy to find the longest chain of this one, so that's not the task here. But now we have to figure out which end, left or right, do we start numbering from. Well, we don't have a third substituent. So again, we are going to have to number starting from the end closer to the chloro group. So I'm going to number 1, 2, 3, 4, 5, 6, 7, right? So our parent chain here would be heptane. And now we just need to figure out our substituents. So I have a chlorine on carbon number 2, so that's going to be 2-chloro. That's how we named that with the halogen. So if it was bromine, it would be 2-bromo. If it was iodine, it would be 2-iodo. And then I have 6-dimethyl. But remember, I have 2 methyls there, and they're off of the same carbon. So I'm going to need to put 6 and then dash dimethyl. Now, you just got to put everything together, and you'll have the name of this guy. So we have 2-chloro dash 6,6 dash dimethyl heptane. Now what you can see is that we need to find the longest chain. So we're going to number this starting, of course, from the right hand side. So we're going to start numbering here. So this one would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have decane as our parent. And then we of course note that we have an ethyl at the 3 position, and then we have this complex substituent over here that we need to deal with. Now it turns out that when you name complex substituents, you count prefixes. So for instance, this has two bromines, so this would be dibromo, right? So for only the complex name, we count this D when we alphabetize. Okay? So we can see off of the 5 position, right? I'm going to put a dash here. I'm going to write that I have now, in this case, we have 1, 2, and 3. So this now becomes a propyl, and I have a bromo on carbon number 1 here, and then again on carbon number 2. So this will be 1, 2 dash dibromo propyl. And so now you would have the name there of this, and we just need to put everything together. So this, of course, would come first because D comes before E. So we would put 5, 1, 2 dibromo propyl dash 3 dash ethyl and decane. And that's how you name that guy.